In this problem, our goal is to be able to break down and figure out exactly what sine of 13 pi twelfths is. The tough part is we don't have exact trig values for things in terms of pi twelfths. We've got exact trig values from the unit circle and our special right triangles that happen in pi sixth increments, pi quarters, pi thirds, and even pi halves. So if we can break this 13 pi twelfths down into a sum or difference of any of these multiples of pi, then we should be good to go. This might take a little trial and error at first, but what we want to try and do is pull this apart into two different, that pen's a little thick too, there we go, two different values. So I'm going to just work on the tens and the ones approach. So 13 pi twelfths could be thought of as 3 pi twelfths plus 10 pi twelfths. Now there's lots of other ways you could break this up, but I think this is one logical way to start it, is to see if you can get just kind of an intuitive breakdown of the number, tens and ones, to end up with a nice reducible fraction of pi. So 3 pi twelfths does turn into pi quarters, which is great. That's one of our values. And 10 pi twelfths turns into 5 pi sixths. That's a reduction there. So now, since we are dealing with a sum, a sign of a sum, we're going to go over to our identities here that I've got pulled up and use this identity. So pop that into place here. This will be sine of pi fourths times cosine of 5 pi sixths plus cosine of pi fourths times sine of 5 pi sixths. Okay, so this is the point in time where we're going to access our unit circle and try to come up with these values. If you have that sitting in front of you, this is going to be easier. I'm just going to do a quick sketch here to point out where I'm getting these. The pi fourths that we see here is in the first quadrant, and the coordinates there are root 2 over 2, comma, root 2 over 2. The other one we run into is 5 pi 6. So 5 pi 6 is all the way in the second quadrant here. And the coordinates for that, if you have your unit circle in front of you over there in quadrant 2, we've got negative root 3 over 2, comma, 1/2. All right. So kind of jumping through this here, the sine of pi fourths will be the y value from the pi fourths angle, and that'll be root 2 over 2. Multiplied by the cosine of 5 pi 6, so that'll be the x value at that coordinate, so negative root 3 over 2. Plus, now we go to cosine of 5 pi, or cosine of pi fourths, so that's the x value at pi fourths, root 2 over 2. And sine of 5 pi 6 will be the y value. All right, so as we complete the arithmetic here, we end up with negative root 6 over 2, or pardon me, over 4, plus root 2 over 4. Okay. Now, do we see this as an option in any of our answers? I believe with the common denominator we could rearrange this. Having a 4 downstairs, we could write that as everything over 4, negative root 6 plus root 2. And since addition is commutative, we could rearrange that as root 2 minus root 6, kind of respecting the sign on that negative radical 6. And this matches answer D. And that is our correct answer. All right, I hope that helped.